this is Mr. Lewis. Mr. Lewis
Yes,
came
it
back
is.
after you heard my cries for help from yesterday's video. So welcome back, Mr. Lewis.
Thank you.
This is video number 28. What is normal CDF? Okay.
Yep. All right, let's hit it.
So here we have an example problem. What do we have, Mr. Lewis?
All right, so here we have a quality control problem with the amount of juice being dispensed from a machine that's normally distributed with a mean of 10.5 ounces and a standard deviation of 0.75 ounces. We want to know what's the percent of dispensed juice that is less than 9 ounces.
Because if it's less than 9 ounces, customers might feel like they're getting ripped off.
Yeah, I would believe so.
So the company doesn't want to do that. They want you to be happy with the product. So, all right. So the first step is to draw the normal curve.
Which we've already done for you down below.
We did a beautiful job with that, didn't we?
Yes.
All right. Now, the second step is to draw a vertical line. That's the middle right there, the midline. And that's the mean of the data. So let's label it below on the x-axis. That occurs at 10.5. So that's the mean.
Right.
And then we're going to draw in a link that represents the standard deviation. It goes from the mean to where the curve switches from opening down to opening up. About right at that point where Mr. Lewis drew it there. Yeah, that distance in the normal curve is 1 standard deviation. So we should label that sigma equals 0.75.
0.75.
Very good. Now, we might accidentally shade over it in a second, but we want to know what percent of juice or bottles are filled to less than 9 ounces. So 9 is less than 10.5. So I'm not going to be really crazy about using a scale. I'm just going to locate about where 9 is.
It's probably somewhere around here.
And label it 9.
9.
And shade the area to the left.
Oh. Wait. Less.
Yeah.
Left. My bad. This.
Yeah, that's okay. So that area.
Left right thing again.
The total area of the curve is 1. That represents 100%.
Yes.
That area that's from 9 and below, that represents the percent of bottles that are filled less than 9. So we just got to find it on our calculator. So to enter the 4 things we have to enter in the calculator are lower limit, upper limit, mean, and standard deviation. So the lower limit, or the mean is...
the mean standard deviation we already know.
Yeah, so cross that out. That should be standard deviation.
Yeah, typo. Here, we'll just abbreviate standard deviation. 0.75.
Okay. The lower limit should be negative infinity. But our calculator can't handle that. So we're going to put like negative 100,000.
Okay. Negative 100,000.
Okay. And the upper limit is 9. So we got to tell it the area falls in between. We're going from negative 100,000 up to 9. That's the upper limit. All right. So here we go. Big calculation here. So second distribution, normal CDF. I'm going to enter those numbers. Upper limit 9, 10.5.
Uh-oh. Man.
Need some comments here.
Yeah.
Oh, man.
Falling apart.
I know. I'll be ready for the next one. Negative 100,000. Comma. Here we go. 9, comma, 10.5, comma, and 0.75, right?
Yep.
So I entered those 4 numbers. It turns out that 2.3%.
2.3%.
So you can see from our diagram that was like more than 2.3%, but this is just a sketch. Yeah, it kind of shows me what the normal curve is and that the area is less than the value of 9. So it's just a sketch.
Exactly.
Okay, let's try the next one. The next one's same problem, but a different question about it. It says, what percent of the dispensed juice falls in between 10 and 12 ounces? So we're going to quickly label the diagram again. Let's draw the midline, or the mean. Okay, and that was 10.5.
Yep.
Standard deviation was 0.75.
Mm-hmm.
And then we're going to locate 10 and 12 lie on either side of the mean. So we're going to locate 10.
Well, 10 probably somewhere around here. And then 12 probably way out here. So let's see. 12 is probably way out here.
Yeah.
So.
And maybe label the cutoff values. So
10.
Yeah, the lower limit and upper limit, those are called cutoff values. So here we go. 10. 12. 10.5.
Mean of 10.5.
And 0.75.
Standard deviation of 0.75. And
72.5%.
72.5%.
Okay, good.
All right.
Let's try another one.
Nice.
Same problem. This time, what percentage of dispensed juice will be greater than 9 ounces?
Greater than 9 ounces.
All right.
Now we're going the other way. See, I was jumping ahead before.
Yeah.
So 9 is probably down here. Let's, this was our 2%. So here's our standard deviation. So we want to go bigger. So now we're shading to the right, which Mr. Lewis wanted to do on the first problem. So we're going to start at 9. We're going to go to positive infinity, or like Mr. Miller said, positive maybe 100,000. Okay. Mean, which was 10.5.
Standard deviation.
Standard deviation of 0.75. Remember, this was SD.
Are you ready?
I am.
Okay, I got this now. 97.7%.
97.7%.
So almost all of them will be filled greater than 9 ounces.
Which is good.
Yeah.
We want more juice.
All right. So those were the 3 types of problems you can ask when we're finding an area. The area below a value, the area between 2 values, and the area above a value. So that's kind of it. If you got that, you got these normal problems.
Right.
Okay. So the last one, on our last slide here, we want to show you a family picture. Isn't that nice?
That is nice.
Which one's the mama normal curve, do you think?
I don't want to say anything too. I don't want to, get on the bad side of women.
All right. But I got to admit, in my family, I'd be the blue one. I'm the tall one in my family.
Yeah, that would make sense.
I'm not going to say whether my wife is the green one or the orange one there. I could get in trouble.
Right, exactly. So that's why we don't. We're going to abstain from commenting.
All right. But anyway, the reason why we're showing you this picture is that the normal curves are a family of curves. There's a different normal curve for every possible mean and standard deviation. So the blue one has mean 0, and it has a small standard deviation. It's not very spread out. The red curve also has mean 0. It's centered about 0, but a wider standard deviation. It's more spread out.
Yeah.
And the orange curve below it also has mean 0, and it's even more spread out.
Mm-hmm.
The green curve has a different mean. It's centered about -2. Okay, and you see its standard deviation is in between the blue one and the red one.
Yes.
So small standard deviation means the normal curve will be really tall and narrow, the area is focused around that point.
Right, because if you think most of the values are in here, so it's going to shoot it up.
Right. And if it has a wide standard deviation, more variability, it's going to be like the orange curve.
Correct.
Much larger range of values.
Yep.
Okay, so in a given problem, we're using one of these. We're using the one that fits the data the best. Okay.
Exactly.
All right, time for the journal assignment.
Journal. All right, so now you guys should figure out there's students in an English class who took an exam in which scores had a normal distribution. The mean score was 73 and the standard deviation was 8. So we want you to draw first a sketch of the distribution of the scores, labeling both the mean and the standard deviation.
Got it.
All right. Then find the percent of students who were under 70.
Normal CDF.
Yep. And would a score of 85 be considered unusual?
Oh, how do we tell if a value is unusual?
Well, usually we can use the standard deviations.
Yeah.
We can look, there's many things that we can do.
And there's a certain letter of the alphabet.
Yeah.
Maybe the last letter of the alphabet.
Right, our Z-score.
I'm not going to give any more hints than that.
Mr. Miller. Like Mr. Miller's hinting at, your Z-score can be used to be considered whether it's unusual, finding how many standard deviations away. So.
You want an even better question? Could we tell if it's an outlier?
We could tell if it's an outlier, but we'll get to that later.
Yeah.
All right.